ladies and gentlemen. Right now we are going to be going into insertion sort, which is the last one for O of n squared time complexity. And that's about it. There's no more. Okay. So after this one, we're going to have merge, quick, and count. And then after those three, we are going to go hash. And that would be the end of the midterm covered. And recursion. Which is actually, probably after this I'll do recursion, then I'll go merge, quick, and the other ones. So what is insertion? Insertion is basically you take one number, you see the right place, and you put it there. Then you take another number, you see the right place, and you put it there. And so on. So how do you do that logically or theoretically? Now, what you always do with insertion is you assume this is the right place. Right? Like there's no reason to change it. Because remember, if I'm taking the 2 and I'm putting it in where it's supposed to belong, then I compare it to whatever behind it. But if I just have a 7, like what am I going to do with it? I'm just going to assume it's in the right place because I can't really, there's nothing behind it, so it makes sense. And so where we start first, we don't set I to 7 because we assume 7 is right. So we go to 2 right away. Now once we're at 2, we grab 2 and then we compare it to everything behind it and then see where the right location is and then we place it. So what we do is first we take 2, we save it somewhere. So let's say we know this is 2. Then I'm going to start looping backwards and I'm going to be like, okay, where do I first start? I need a second letter. That's going to be J, and it's going to be the one behind, the one directly behind it. Then I'm going to start and be like, okay, does 2 go behind this or after it? If it goes behind it, then the 7 has to shift here so the 2 can go behind it. And then, but I don't replace the 7. I keep it so it'll be 7, 7. Because remember, I saved the 2. Then I'm going to be like, okay, what about the one behind this? Let's say there's like a 6. Does it go behind it? It does. So then I shift the 6 here. And then so on until I find the place. And then I replace that. And so that is basically the idea of insertion. So just like always, the first thing you start with is a for loop. And then we're going to int I equals 1, not 0. Because we're assuming the first one, at index 0, the first element is at the right place. Then we're going to have I less than the array dot length. And now for dot length, once we get to the last one, you still need to sort it. Because remember, let's say I take the 2, I sort it, the 2 goes behind the 7. Then I go to the next one, which is the 7. Well, sorry, not the 7, the 9. And the 9 doesn't go behind the 7 or the 2, so I leave it. Then I go to the 6. The 6 goes behind the 7, so 6 goes here. So the 6 will go here, the 7 will go here, and then I will go here. When I get to the last one, I still got to take the 4 and put it in the right place. So I do want to get to the last one. All right? And so that's why we just do array.length plus plus. And now I start. Now I got to take whatever my I is at and save it somewhere because I got to take that, find the right place, and drop it. So I'm going to do an int, and I'm going to, this is the key. This is basically the current number that I'm trying to find the right place to. All right? And that's going to be at array at I, right? But we don't really work with numbers. Wait, do we? Yes. Actually, here we do work with numbers because we want to compare the two numbers. And we're going to use the key to compare it to the other numbers and see where the right place is. All right? Now, after we got the key, we got to have our J. Now, you'd think, well, then make a for loop and introduce J. However, we don't know how many steps behind that number. So let's say I need to take 4 and I need to put it in the right, let's say here, I need to take 4 and I need to put it in the right place. I don't know how many loops I have to go backwards for the right place. Because let's say this is the right place where 4 is more than 2 and less than 9. Why would I go behind 2? Because remember, everything behind that number I'm trying to sort is assumed to be sorted. So why would I go more? Whenever you don't know how many loops you make, it's a while loop. All right? And so since it's a while loop, I'll have to make the letter J. And so J is going to be I minus 1. Why minus? is because let's say I is here, right? J, I want to compare it to everything behind it. So J will have to go to the one right behind I and backwards, not including I, because why would I compare it to itself, right? So that's how it would work. Then I'll go while. What is my conditions? Well, while J is more than or equal to 0, that's the first condition. Here, let me do this so I don't get any errors. This is my first condition because once J gets to that position 0, I want to check that 0 just in case the key I'm holding is supposed to be at 0. So I do want to check 0 because what if, for example, 2, what if 2 is supposed to be at position 0? So I do got to take in 0. That's why it's equals. It's more than or equals to 0. So that if it's more than 0, it will keep looping back until it finds the right place. And if it's equals to 0, I still want to loop that 0 to make sure is this the right place for it. And then once I check also the zeros indice, which is the first element, then after that I'll exit because there's not I don't want to go negative because you'll get an out of band error. What's my second condition? The second condition, this is where you want to go whether you want ascending or descending, right? So if J, so what we want to do, if the array at J, which is going to be the 7, right, is less than the array, or, well, less than the key. Well, I was going to do array at key, but I remembered we're not holding indices, we're holding the number. So what does this say? Is J less than the key? So is J less than the key? No. So this is in what? This is in descending order. So let's do ascending. Now is J more than, is the array at J more than the key? It is. So therefore I want J to move forward 1. And so we're going to move J forward. So we're going to say, okay, then array at J plus 1, right, because that's the one after J, equals array at J. So now I moved it forward, right? So then I said, this is J plus 1. I said J plus 1 equals J. So now this became 7, right? Now, after I do that, I'm going to do J minus minus. And what that means is, well, right now I can't go backwards more. The while loop will break. So let's choose another number. Let's do a 6. Actually, let's do the 4. So what happens is, let's say this is J and this is I. J became, so J plus 1 became J. So this became 6. Then it's going to loop back. J will do minus minus. So now J is here. Then I'm going to be like, well, is J, remember the key is 4. Now I'm going to be like, okay, is J more than the key? Is J, so is 9 more than 4? It is. So I'm going to move it forward again. And so on. Okay, and then we'll move backwards. Oh, actually, let me keep the 4. And then it will move backwards to here. So this is where J is. And now I'm going to be like, okay, is 2 bigger than the key? And that will be false. Since it's false, the while loop will break. Now when it's broken, where do I want to place the key? I want to place the key at J plus 1. Because remember, 2 is where it broke. So I want to place it at the one after it. And so this will equal the key. Okay? And then that's about it, I believe, for this one, if I can remember it correctly. Let's see, 7, 16, 22, 31, 33, 35. Yeah, that's about it. Let's run it one more time to make sure it does it properly with double. So you see I have 16, 16, and then, so that's right. Now I can move this to less than, and you'll see, what, did it save? Yeah, so you see it flipped. So now it's descending instead of ascending. And that's about it for insertion. It's the shortest one, but it's a little bit trickier just because you're not familiar with it. It's not 2 for loops like selection and bubble. But in terms of amount of code you're supposed to code, it's short. This is also O of n squared. And the reason this one O of n squared, even though you don't have two for loops, for every loop you do, the while loop will go backwards a exponential number of times. So if the array is 10, for every index you get in the right position, on average, you'll loop through the whole array, which is, let's say it's 100 loops. And then when you add one more, which is 111, for that extra one, you're gonna loop through the 11. So it's gonna add 11 onto it. And so that's why it's n squared. And that's about it for insertion. It's a pretty short one. After this, like I said, I'm gonna go into recursion. And well, I'm gonna do recursion, backtracking, and tail recursion all at once. All right, so I'll see you guys in a bit.